we can go back. And please review your own test. Test 3, review it. Test 2, review it. Okay, do we need to differentiate this?
Yeah, can we do it real quick?
Yes, of course. So f of x equals natural log of 9x. So natural log of a function, prime. So f prime of x equals 1 over the function times the inner function prime. 1 over the function times the inner function prime. We simplify the 9 and we get 1 over x. Is this okay? Yes, please. Is this okay? Okay. Going back. 5. Is this okay? Do we want to work on this?
Yeah, can we do this one?
Of course. So we have f of x equals natural log to power 7. It's a function to a power. So f prime equals 7 natural log x to the 6th power times the inner function prime, which is 1 over x. So we bring down 7, we subtract 1 from the power, but we can never ever forget times the inner function prime. Times the inner function prime. You have to get used to saying that in your head, times the inner function prime. Okay, so let's look at number 6. Critical points. They want critical points. They want max min, where the function is increasing or decreasing, points of inflection, intervals in which the function, where the function is concave upward or concave downward. And then sketch the graph.
This is the one where we make the chart, right?
Yes,
Can we do it, please?
of course. So we have h of x equals 4x to the 3rd minus 48x. Perfect. So in other words, I have to determine everything. So let's determine everything. Okay, so I'll get my table going. H prime of x, h of x, and the second derivative. And this is nice because it's a polynomial function, and the domain is all real numbers. First, I will determine these limits. So the limit as x approaches negative infinity from 4x cubed minus 48x. And then the limit as x approaches infinity from 4x to the 3rd minus 48x. With polynomials and infinity, here's my thinking process. Which of these two terms is the powerful one when you talk to infinity? If we talk about x equals 3, everything is important. But when we talk about infinity or negative infinity, only one of these dictates. Only one of them is powerful. Which one? First or second?
Be the x cubed.
Indeed. It's always the degree. Good. So imagine you plug in negative infinity. What is the answer? And then here imagine you plug in infinity. What is the answer? In other words, negative infinity to the third and infinity to the third. That's all I'm asking.
It just goes to negative infinity and positive infinity on the other side.
That's it. Now I have to set it equal to 0 because I want to find the x-intercepts. And there must be 3 intercepts or 3 solutions. Maybe some of them are imaginary. I don't know. But I expect 3 solutions. So 4x to the third minus 48x equals 0. Of course, I'm going to divide both sides by 4 to simplify the equation. Never divide by x or expression with x. No, never. But you can clean up factors. Like we were able to make up factors in the integration. Yeah, who cares? 4 times 1/4 is 1. Okay, so then we have x to the third minus 12x equals 0. This looks more human. Now, of course, I have to factor out x. And I get x squared minus 12 equals 0. And I do get 3 solutions. X is 0. And from here, x squared equals 12. Remember, one option is to take the square root. So x equals negative the square root of 12, and x equals the square root of 12. Now, you don't even have to do this, because you can plug it in the graphing calculator in apps, in the polynomial root finder, and you will find 3 solutions, and they will also be approximated for you. So you go to the graphing calculator, you go to apps. If your calculator doesn't have this, you can borrow a calculator from the testing center, please. Okay, so the degree is 3, careful. And then I have to enter the coefficients correctly. Be very careful now, because the first one is 1 after simplification. The second one is 0. The next one is negative 12. And the last one, which is the free term, that is 0 as well. So the solutions have to be 0, 3.46, and negative 3.46, as we determine them. So this is 3.5 with negative, and this with positive. So I have to put them in the table. 0, negative 3.5, 3.5, and 0, and 0, and 0. I exhausted the function. I found the x and y intercepts, and I found the limits. There is nothing else I can find about the function from the function itself. Now I have to go to this first derivative and try critical numbers, and then the second derivative and find those critical numbers which will probably turn into inflection points. So I continue with the function. So h prime of x equals 12x squared minus 48, and the second derivative 24x and nothing else. So when I set h prime equal to 0, because h prime can never be undefined, y can never be, because it's a polynomial. The square root can be undefined. Natural log can be undefined. Rational functions can be undefined, but not polynomials. So when I set this equal to 0, I get 12x squared minus 48 equals 0. Or when I divide both sides by 12, I get x squared minus 4 equals 0. I know that this is plus or minus 2. So these are the critical numbers. And there is another critical number from, in other words, I put inflection point, when x is 0. Because the second derivative will be 0 when 24x equals 0. Okay, so I have everything I need. So a negative 2 and 2 and 0. Positive and negative 2. Negative 2 and positive 2. The first derivative is 0. And the second derivative is 0 when x is 0. Now I have to study the sign of the first derivative and the sign of the second derivative. The second derivative is very easy because when x is negative, this is negative. And when x is positive, so this has to be opening upward and this downward. I already know that this must be an absolute relative max, and this must be a relative min. How do I know? From here. So there is a critical number in this territory. So, and the function looks like this. So this has to be a relative max. In this territory, the function looks like this. So this must be a relative min. I have to put the function in the graphing calculator and determine the corresponding values for negative 2 and 2. Because I need all those y values in here. So I'll go back to the graphing calculator. I put the function in. And the function is 4x cubed minus 48x. That's not what I meant. 4x cubed minus 48x. And I want to determine, the function is odd, so when I determine for negative 2, the same thing I'll get for 2, but with the opposite sign. So 64 and negative 64. Yeah, so at 2 is negative 64 as expected, yes. Negative 64 and positive 64. Okay, so now I have to study the sign of the first derivative just in case. In between solutions, I put in 0, so it's negative. And outside is positive. Because I plugged in 0 and I got negative 48. And let's see. Increasing, and then further increasing, and then decreasing to 0, decreasing to negative 64, up to 0, up to infinity. And it matches. So it's a relative max, of course, as expected. It's a relative min, of course, because of the sign. Increasing and decreasing. So this is a relative max. And then decreasing and then increasing. So this is a relative min. And this is the IP. At 0, 0, the function changes concavity. So we're ready to graph it now. The only thing we need is the table, nothing else. So 1, 2, 3.5, negative 2, 0, 1, 2, 3, and 2. Okay, so I got my values. So now I have to plug in, create the points. Okay. At negative 3.5, the function is 0. At 3.5, the function is 0. At 0, the function is 0. But now, at -2 is positive 64. So I'm going to say 10, 20, 30, 40, 50, 60 right here. And the same thing on the other side. 10, 20, 30, 40, 50, 60, and a little bit. So now I read from -infinity up through the point of intersection on the x-axis. Then it's coming down. How do I know? So it's going up, crossing the x-axis, up to positive 64 and comes down to 0, 0, 0, 0. Where it changes concavity, opens up, goes to the minimum, comes back up, goes to the minimum, comes back up to infinity. So this is the graph of f of x equals 4x to the third minus 48x. So when they are asking us to fill it in, the function is increasing from -infinity to -2, union from 2 to infinity. The function is decreasing between -2 and 2. The function is opening up downward from -infinity to 0. The function is opening upward from 0 to infinity. The function has a relative max at -2, positive 64. It has an inflection point at 0, 0. And it has a relative minimum at 2, negative 64. Is this okay? Perfect. Determine the horizontal asymptote of the function. Because the degree of the top is higher than the degree of the denominator, this function has or has not a horizontal asymptote. Rational functions have horizontal asymptotes only if they have the same degree over the same degree, or if the degree in the denominator is larger than the degree of the numerator. So this function does not have a horizontal asymptote. It has a slant asymptote because the degree of the numerator is 1 unit larger than the degree of the denominator. So again, only 2 functions, rational functions, have horizontal asymptotes. Only when the degrees are the same degree over same degree, or when the degree of the denominator is larger than the degree of the numerator. When the degree of the numerator is larger, there is no horizontal asymptote. Is this okay? Okay, so you have to select no horizontal asymptote. Okay. Sketch the graph of the following function. So this is the same situation, but a different function. This is a much easier situation than all the polynomial, because these functions don't have max min. They're increasing, decreasing, but they don't have max min. And they don't have inflection points. So let me know if we want to look at this one. Okay. Find the absolute max and absolute min on a closed interval. We are given the interval -1, 0, and we have to find critical numbers and study the sign of the first derivative. That's all we need to do. Is that a yes? Find the absolute max and min on a closed interval.
Can we look at this one?
Yes? So the function is f of x equals 2x to the third minus x squared minus 4x plus 10, and the interval is -1 to 0. So we have to create a table, but only with f prime and f of x, nothing else. And only between -1 and 0. You cannot extend anywhere. This is what is given to us. All I need to find is f prime, which is 6x squared minus 2x minus 4. I set it equal to 0. I use the calculator to find the solutions. So let's use the calculator. And with apps and number 9, and it's polynomial root function. So this is a quadratic function equation. So the leading coefficient is 6. The middle coefficient is -2 and -4. And then I find -2/3 and 1. So x equals -2/3 and x equals 1. But 1 does not belong in -1, 0. I cannot use it, but I can use -2/3. So I need to study the sign here and here. So when I plug in 0, I get -4. And when I plug in -1, I get positive. The only step that is missing here is to find the values of the function at these 3 points. So I plug in the function in the graphing calculator and plug in -1, -2/3, and 0. I know 0 is 10. 0, 0, 0. That I know. Okay, so let's put the function in. So in y equals clear 2x cubed minus x squared minus 4x and plus 10. So all I need to plug in is -1 and -2/3. So I got at -1 we have 11, and at -2/3 we have 11.63. Now I have to make sure that my information is correct. So let's check. From 11 to 11.63, yes, it's increasing, that's correct. From 11.63 to 10, yes, that's correct. So now I will make my conclusions. So this is definitely the absolute max, and also relative max, and this is the absolute min. It cannot be a relative at the end point. And of course, this one is nothing. Okay, let's look at 10. We're given a function, we're given x, we're given delta x, and we're asked to find delta y, dy, and dy. Now, by now, you got very familiar with this dy, the differential of the function. That's why I said a long time ago, we need it for chapter 4. And for everything else. Differential equations and chapter 5. Is this a yes? I know you're tired.
Yes, could you go for this one?
Yes. And then we'll stop after this one, I promise. And we'll come back, we'll reconvene on Monday from number 11. Good, so here we have y equals f of x, which is 2x minus 1, a very easy function because it's linear, and delta x equals 2. So remember, we have to just use two notations, f of x plus delta x minus f of x, and as we know by now, dy equals f prime of x dx. So these are the two functions, or the two formulas that we have to use. That's the whole thing. And we just plug in the numbers. So for delta y, I have f of x plus delta x, which is f of 5, minus f of x, which is f of 3. For dy, I have to differentiate, and I have 2 dx. So it's 2 times dx, which is 2. The delta x and dx are the same. So in f of 5, I plug in 10 minus 1 is 9. When I plug in 3, 6 minus 1 is 5. So they happen to be equal.